Welcome to the video on Design Consideration in Tall Buildings. Now that you know the elements in a framed structure, and the load transfer strategy in a structural design, you will go on to understand the desired outcomes of a design process. Structural engineers need to consider the following desired outcomes of structural design. The designed structural members should withstand the internal forces generated as a reaction to the loads on the building. You will calculate these forces by doing structural analysis. These sections must not fail structurally. When faced with a choice of multiple structurally stable designs, economics of the project should be a vital parameter. Keeping these in mind, you have to compute the specifications, which are cross-section dimensions of the elements, the grade of the materials in them, and the amount of reinforcement, if they are concrete materials. To assist with the preliminary design process, a list of standards is prescribed to a civil engineer while designing structural elements. The two major Indian standard codes followed for building design, which we will be primarily using in this course, are IS 456 for design of plain and reinforced concrete structures, IS 800 for design of steel structures. You can download these codes in PDF form from the link provided in the next page. Likewise, there are standard codes for other countries too. For example, the American Concrete Institute's 318 is a design code for concrete design in America. These codes differ primarily in the provisions, or standard specifications for design of buildings, based on local construction norms, and available material properties. There are also some standard design materials and sections used in India for structural design. The available concrete grades are M20, M25, M30, M35, M40, etc., where the number next to M represents the compressive strength attained for concrete after 28 days of curing. For example, M30 has a compressive strength of 30 Newton per millimeter square. For the steel reinforcement bars, you have different grades, like Fe 415, Fe 500, mild grade 250, etc. An Fe 415 bar would have a minimum yield stress of 415 Newton per millimeter square, and so on. In the design of steel structures, you have different steel sections, with grades of steel like Fe 250 and Fe 345. In steel design, there are some steel sections with predefined sections, which are available in the market. These sections are available in the Indian Steel Table database, from where you can refer and choose the required dimension. The common steel sections are ISMB series, ISWB series, ISHB series, ISJB series, etc. These series, meaning Indian Standard Medium Weight Beam, Indian Standard Wide Flange Beam, Indian Standard Heavy Weight Beam, and Indian Standard Junior Beams respectively, are different broad categories under which the sections of different dimensions are listed. And so, the process of structural design for the civil structural engineer is essentially as follows. As input, you need information about the loads the building will be subjected to, the building architectural plan, and the available materials and elements sections, which you will be using to design the elements. Once you have this information, you will perform structural analysis by applying the loads onto the structural elements and checking the internal forces, stresses, displacements and other results for any failure. These results will aid you to design the to the IS codes for design. In this process, you will finalize the elements sections, the materials used, and the reinforcement detailing, which will complete the design process. In the next video, you will learn about the software used in tall building design. Thanks for watching.